Okay, so second module of factoring. Okay, so the second module deals with much the same thing, except the big difference here is we're looking at 2 terms instead of 3 terms. So there's something special that we can generally do with 2 terms that will make our life a little bit easier. Okay, it's kind of outlined for you here. It's called a difference of squares. So let's kind of analyze what that means. So a difference, remember, is subtraction. So it's got to be subtraction. And then we have to have perfect squares. So they won't necessarily have a square marker on them, but they do both have to be perfect squares. So some perfect square numbers are like 9, right? Because I can take the square root of 9 and get 3. 16 would work because I can take the square root of 16 and get 4. 49 would work because I can take the square root of 49 and get 7. Variables, you're going to have like x squared is a perfect square because I can take the square root of that. X to the 4th. Anything that you can take the square root of. Remember, odd exponents are not good. So if I have like x to the 3rd, that's not a perfect square because I can't take the square root of something to an odd exponent. Okay? So what you very simply do is you take the square root of the pieces. So the square root of a squared is a. The square root of b squared is b, and then you add them, and then you subtract them, and that's literally it. So let's look at a couple examples here. Okay, so in number 1, I see it as a difference, right, because of the minus sign in the middle, and these are both perfect squares, because I take the square root of s squared, and that's going to give me s. The square root of 49 is 7, so I set up my 2 parentheses, s plus 7, and s minus 7. So there always has to be 2 of them. They always have to be plus or minus. Okay? Alright, let's go ahead and look at 4 down here. Okay? So I see that it is a difference, and I see that these are perfect squares. The square root of 4 is 2. The square root of g squared is g. So that term together is going to be 2g. The square root of 25 is 5. So I get 2g plus 5, and then the second one's the minus, 2g minus 5. Okay, so it's a difference of squares. This is what we use when we have 2 terms. So if you have 3 terms like we did on the previous module, you cannot do this. It's only when you have 2 terms. So go ahead and pause the video. You can work through the other 4 problems and then go ahead and play it when you're ready for me. Okay, so for number 2, square root of t squared is t. Square root of 81 is 9. So I get t plus 9 and t minus 9. Okay, for number 3, 16 is 4. Square root of 16 is 4. Square root of x squared is x. So I'm going to get 4 plus x and 4 minus x. And I know it looks weird on that problem having the x at the back, but you have to follow the same order that the original problem was. Alright, number 5, square root of 36 is 6. Square root of h squared is h. Square root of 121 is 11. So then I do 6h plus 11 and 6h minus 11. And last but not least, number 6, square root of 81 is 9. Square root of 49 is 7. Square root of k squared is k. So then I have 9 plus 7k and 9 minus 7k. Ooh, not x, k. And I'm done.